This video is going to cover section 2.5, testing for validity using the true-false method, but we're going to use the indirect approach. So this is the last section in chapter 2, and this is going to give us a way to test for validity of an argument if we're unable to directly figure out an argument's validity using the true-false method, because there doesn't seem to be a relationship between the premises. So we have to kind of think of other methods. And this indirect approach is another method. So our strategy is, what we're going to do is we're going to assume right off the bat that the argument is invalid. So in other words, we're going to assume that the premises are true, but that the conclusion is false. So if we can then provide truth values for all the variables such that the conclusion is false while all the premises are true, then we just proved that our argument is invalid, because we just showed that when the premises are true, the conclusion is false. So we were assuming correctly that the argument's invalid. However, if we're unable to do this because we find ourselves in a contradiction, then our original assumption must have been wrong, right? Because we contradicted ourselves, and then the argument's going to be valid. So I know that sounds a little confusing just by explaining it, but you'll see once we do a few examples, it'll start to make sense. But we can't just use this method anytime. We can only use this method in 3 cases, and I highlighted the 3 cases here. So this indirect approach is only going to work if the conclusion is a single letter, if the conclusion is an or statement, meaning a disjunction, or if the conclusion is a conditional statement. Because for each one of those, there's only one way for the statement to be false. So let's just start. Like I said, I think after we warm up and do a few examples, it'll start to make sense how this indirect approach works. So remember what we said. We said, okay, with the indirect approach, we're going to assume that the argument's invalid. Let's just assume right off the bat that the premises are true and the conclusion is false. And again, I could do this because the conclusion is a single variable. So the only way that the conclusion would be false is if A is false, right? A would have to be false. It's a single variable. Now, then that's going to let us figure out the values of the rest of the variables in my argument, right? Because I could say, okay, A is false. So then that means A is false. I have an or statement, and the only way an or statement is true is if one side is false, then the other side would have to be true, right? So that makes S true. And we have not S over here, right? So that's going to be false. And we also have A over here, so I'm just going to label that as being false. And the fact that not S is false and it's in an or statement, and the or statement has to be true because we're assuming the premise is true, then that makes this conjunction, it has to be true, right? And the only way the right-hand side is going to be true, this conjunction, is that both P is true and W is true. So then that makes W true and P true. But this doesn't make sense, right? Because look, maybe I'll highlight it. You see how this statement right here would become a true implies false, right? Because if we're saying P is true and we're already saying A is false, then the right-hand side of this conditional is going to be false, right? This statement would be false. And then we would have true implies false, which is false. So it's contradicting the fact that we're assuming the premise is true, right? So we just contradicted ourselves. So the fact that we contradicted ourselves means that this argument is in fact valid. It's not invalid like we assumed right off the bat, right? Because we assumed the conclusion was false when the premises are true, but we just showed that this premise wouldn't be true, right? So we just contradicted ourselves. So therefore, we could say that the argument is valid because of that contradiction. So let's look at example 2. We have a single variable as our conclusion. So we could use this indirect approach. Let's assume that all the premises are true and the conclusion is false, which would make R false, right? That's the only way the conclusion would be false. So go to your first premise. We can make R false. And the only way this conditional would be true, right, because we're trying to show that it's true, is that D would have to be false. So then D is false. And we could also say that A and B, right, if that it's an and the premise is true, the only way an and statement could be true is that both the left and the right-hand side are true. So that would make A and B true. So then B would be true. Now, the only value that we can't figure out right now is C, right? So let's think about this. Well, not that we can't figure out, but we haven't figured that one out yet, right? So let's think about if we could force C to be something, or if it's possible, that it could be either true or false. The left-hand side of this statement is an and statement, right? But in order for this second premise to be true, this and statement has to be false. Because if it were true, I'd have a true implies false because D is false, right? And that would make the premise false. So that statement has to be false, which then forces C, right, to be false. Because a true and a false is false. If it were true and true, that statement would be true, right? So the fact that we were just able to figure out what the truth value of all the variables are in our argument, and we didn't contradict ourselves, leads us to believe that when we have all three premises being true, it is possible to have a false statement. So we just confirmed, or we just showed, right, that our argument is invalid because what we just figured lines up with the assumption that the premises are true and the conclusion's false. So since we weren't able to contradict ourselves, we have to assume, like we did from the very beginning, that this argument is invalid. And my counterexample, so we have A, B, C, D, and am I missing anything? Now A, B, C, D, and R. So we said A is true, B is true, C was false, D was false, and R was false. Right? So we figured out all the variables' truth values, right, that remain consistent with an invalid argument. So that would be our counterexample. Let's look at example 3. I have 3 premises and a conclusion. My conclusion is a conditional. So remember, that's one of the requirements in order to use this strategy. Either the conclusion is a single letter, the conclusion is a disjunction, or the conclusion is a conditional. So let's assume that the argument is invalid, meaning the premises are true, the conclusion's false. The only way a conditional could be false, right, is if the left-hand side is true, the right-hand side is false. So that makes not D true, G false. So then I could say, okay, D in the first premise is false if not D is true. and G we just said is false. And the only way a biconditional is going to be true, right? Because I have a biconditional. If the right-hand side is false, G is false, the left-hand side has to be false. And the left-hand side is an or statement. The only way an or is false is if the left and the right-hand side are false. Well, D is already false, right? So C would have to be false. So then C is false, right? I could label C down here as being false. A, since it's our third premise, we're assuming is true. So then the left-hand side of the second premise, A, is true. And in order for the premise to be true, if it's a conditional, then the right-hand side has to be true, right? Because if it wasn't, we'd have true implies false, which is false. So the right-hand side has to be true, and it's an or statement, and C, the right-hand side, is already false. So B has to be true. And now we just figured out every letter, right? We assigned a truth value to A, B, C, D, and G. And we didn't contradict ourselves, right? This shows that it is possible to have all our premises be true, but our conclusion false. So this argument is invalid, since we just showed that it's possible to have a false conclusion when our premises are true. So let's just list when that would happen. What are the truth values for A, B, C, D, and G? So we said A is true, B is true, C is false, D was false, and G was false. So that's my counter example chart. So let's go to example 4. So for example 4, I have 4 premises, and I have a disjunction as a conclusion. And remember, if I have a disjunction or an or statement as my conclusion, I can use the indirect approach. So let's practice using the indirect approach. Let's assume all the premises are true and the conclusion is false. The only way a disjunction or an or statement could be false is if both the left and the right-hand side are false, right? So C would have to be false, R would have to be false. So let's find C and R in this problem, in this argument. We could label them, right? So I have a not R, so that's going to be true since R is false. And then C over here is false. Since my first premise is a conjunction, an end statement, P and not S, the only way an end statement could be true is if the left and the right-hand side are true. So I could say that P is true and not S is true. So then I could label P down here as being true. And if not S is true, that means S is false. I could also say, so C is false. Not Q has to be true, because if it were false, then the conditional statement for the second premise, since the left-hand side is true, it would be false. So not Q is true. Which then makes Q false. So Q over here is false. And a false or a false is false, and that's the right-hand side of a biconditional. And the only way a biconditional statement can be true if the right-hand side was false, that means the left-hand side would have to be false also. So not A would have to be false, which then makes A true. But look what happens. So A implies S, true implies false is false. And a true to a false is false, which is contradicting this third premise, right? The truth value. We're assuming it's true, but we're showing that it is possible that it could be false. So we just contradicted the argument that this argument is invalid, right? Because we just showed that when all the premises are true and the conclusion is false, right? That's not the case. We could contradict that assumption that the argument's invalid. So since there was a contradiction, the argument is valid. And let's do one more. Example 5. We have a single statement as our conclusion, so we could use the indirect approach. So let's assume our premises are true, the conclusion is false. So that means not S is false, which then means S is true. And P and Q, we're assuming is true, right? So that means that P is true and Q is true. So then not Q is false. And P down here, P we said is true, right? So this is true. So we have true or true is true. Now let's look at the second premise, right? Because let's see, because we have to figure out R, right? So we have a conditional, the left-hand side is true. So in order for this premise to be true, this or statement has to be true. It can't be false, or else we'd have a false premise. So what's the only way this or statement could be true if the left-hand side of it, not Q, is already false, right? That means that R has to be true. So we just showed that we're able to figure out a truth value for all the variables in this argument, and that the premises are all true, but it can lead to a false conclusion, right? So we just validated the argument, in other words, not this argument, but our argument at the beginning, right? That we went into this saying this argument's invalid. So we just proved that because we couldn't contradict ourselves, right? So this argument is invalid. And the counterexample, so we have P, Q, R, and S, would be when P is true, Q is true, R is true, and S is true. So that would be the truth values for P, Q, R, and S, such that we have all premises being true, but leading to a false conclusion, therefore making this argument invalid. So that wraps up section 2.5. I tried to do a variety of different problems. You know, we did 5 different examples, but the point of this is when you're going to use the indirect approach, assume right off the bat the argument's invalid. Set your premises to all be true and your conclusion false. But remember, your conclusion either has to be a single letter, a disjunction, or a conditional statement, just like all 5 of these examples. And if you can't contradict yourself, then the argument's invalid. If you can contradict, then we just showed that the argument's not invalid, therefore it's valid.